We are now set to look at the derivatives of the sine and cosine functions. To do this, we need to remember the limit definition of a derivative, given here as the limit as h goes to 0 of f of x plus h minus f of x over h. We'll need to know trig identities, either for sine of a plus b or for cosine of a plus b, depending on which trig function we're taking the derivative. And we need to know a couple limits that we found using the squeeze theorem, namely, the limit as h goes to 0 of sine of h over h is equal to 1, and the limit as h goes to 0 of cosine of h minus 1 all divided by h is equal to 0. Using these properties, we can now determine the derivatives for the sine of x and the cosine of x. So our example today, we'll look at the derivative of sine of x. So our first step will be to use this limit definition for our specific function sine of x. So we can write that dy dx is equal to the limit as h goes to 0 of sine of x plus h minus sine of x over h, f of x plus h minus f of x over h. Here is where the sine of a plus b identity comes into play. We can now replace sine of x plus h using that identity, and we can write the limit as h goes to 0 in front. Don't forget to keep that in your problem until you take the limit. We have sine of x times cosine of h plus cosine of x times sine of h. So all of those two terms replace sine of x plus h, and then minus sine x all over h. Our next step is to group together the two sine of x terms in the numerator. I have sine of x times cosine of h, and I have minus sine x. So we'll group those together in the front, and we'll see that we now have sine of x all times cosine h minus 1, where that minus 1 is the placeholder for this minus sine x. And then our middle term that we didn't touch, plus cosine x sine h, all over h. Now, if we have a fraction here where the numerator has a plus sign, we can divide that into two separate fractions, both over the same denominator. So we can take this sine of x cosine h minus 1 and divide it by h, and then separately add cosine of x plus sine of h all over h. So we're going to do that in order to take our limit. And we'll use the property that the limit of a sum is the sum of the limits. So when we write this out, I'm going to do one additional step, and that is pull this sine of x out from this piece here, the first part of my fraction, because there's no h's involved. So it's not affected by the limit as h goes to 0. So I have sine of x times the limit as h goes to 0 of cosine h minus 1 over h. I'll do the same thing for the last term. I'll pull out the cosine x and multiply by the limit as h goes to 0 of sine h over h. Notice that these two limits are exactly the limits we have here on the left from the squeeze theorem. So we can simply replace them with their appropriate values. So this first limit involving cosine becomes a 0, and then I add cosine of x plus this limit that involves the sine is equal to 1, and this reduces to cosine of x. So we see that the derivative of sine of x is exactly equal to the cosine of x. Now you can go through the same process to find the derivative of cosine of x, however, make sure you use the trig identity for cosine of a plus b, which is slightly different than the identity that we used here for sine of a plus b.